So what we want to talk about is using large language models, LLMs, for the purposes of analysis.
Hmm.
And that can be done, we know that, but there are some limitations. And so we want to delve down into what those limitations are and why they exist, and how you need to be careful when doing this, and what the right way of doing analysis using large language models is. And so to do that, we need to talk a little bit about how LLMs handle numerical things, handle numbers, and why they are unreliable for that. But to do that, it's probably a good idea to break a little bit down how they work, what they do well. So, do you want to give us a quick précis of that, Pete?
Yeah. So of course we're talking technically here about LLMs, and in the general sphere of the world, people calling it generative AI for better or for worse. But that's generally driven by large language models. I kind of put it in my head into sort of three categories: good, the bad, and the ugly. Um, and also think this really affects how, as humans, we perceive them, because the good is really good. And when, and I'm sure everyone's had this experience when they've tried out using some generative AI and large language model on some sort of use case they've got, and they find out that it's really good, and sometimes it's so good it leaves you slightly gobsmacked. And in the technical world, they're generally pretty good or very good, sometimes absolutely amazing at producing code. I know it's not everybody's business, but it's why there's a lot of buzz around this. So you can ask it quite complex, give it quite complex instructions, and it'll produce the code for you, and it's pretty accurate. And not only is it a great starter, sometimes it's like it's just the code just works and it's just great and you can move on. So it's really good at that. And when you have a tool that's that good, it sometimes blinds you, and you go, "Oh wow, this is just if it can do that, it must be able to do anything." And so you get that sort of halo effect. And then there's the sort of bad, which is where we get into the sort of inconsistencies, and people call it hallucination, where you ask it something and it comes back. I mean, it's not right, but it sounds supremely confident about it. And of course, to keep on the coding example, it would give you code, but that code might not work. It actually just might be wrong, and it fails or doesn't do what you want. And you start to get into risky territory here, because if you're not that familiar with coding, it gives you something. If your code doesn't work, as most coders know, that's kind of the easy problem. You run it, it fails, and it says you have an error, and you can go and fix that and really see what you're doing wrong. The more insidious types of errors you get, the typical bugs, where the code works, but it's not doing what you expect. So the output you're getting is wrong for one reason or another. It's done a calculation which it shouldn't have done. And so you can get that back. You can get that code back. It can be wrong, give you the wrong results. And then the question comes about, how do you know? If you're not that good at coding, which is why you've asked to do it, maybe, are you really good at checking it? And so then you start getting to sort of dangerous territory, and people see this, with asking it questions about things, especially models which don't have recent information from the internet. You ask it a question and it gives you something that's a couple of years old and it's just wrong, right? And then it starts to
Well,
make
let's
things up.
just for a second understand what's going on there, because I
Yeah,
think it's quite important,
yeah,
right?
absolutely.
So, when we talk about things like hallucinations,
Mm,
or just getting stuff wrong, and the lines are blurry there, and I think a lot of people are not very happy with the concept of labeling these things hallucinations.
indeed.
They What we're talking about here is where a large language model, something like ChatGPT, you could ask it a question
Mm,
about the England football squad for the last World Cup, and who the goal scorers were, and it might just give you, like, a completely wrong answer, like Elvis Presley scored the most goals or something,
Mm.
right?
Mm.
And that's obviously bad, but it will present it to you as if it was fact.
Indeed.
And that's going to cause lots of clear problems. And we use a very simple example like the fact is, well, clearly that wasn't, well, I assume it wasn't Elvis Presley. I don't think there's any England footballers with that name. That it can get it wrong in much more insidious ways, right? In that when you've got 10 words as a response, you can maybe see where the issue is. But if you've got 1,000 words as a response and the answer is distributed through that, then it might be a lot harder to tell what the issue is.
Yeah.
The reality is that in reality the LLM hasn't got anything wrong. It just has statistically inferred an answer that for something it has a very poor representation for in memory.
Yeah, and I think that halo effect of the amazing result comes in again here, because if you think about doing a search, which you go into a search engine, most people use Google. You ask a question, it brings you back a list of results, and then what you're doing is you're looking at one or two and you're sort of comparing them, and you're going, oh, okay, well, read this here, oh, this one's completely different, and then you're trying to make that decision. Whereas when you ask a question of one of the large language models and it comes back, it's just putting it all into one big blob, as you say, and it's just talking about it, and you'll see things which you're familiar in there. And hey, when I asked it the question earlier, it was 100% right, and now I'm asking it a slightly different question, and it talks in exactly the same way. It's just as confident. Oh yeah, this happened. I mean, I to give a concrete example here, I asked it to write like a 300-word summary of the Australian Open final in tennis, and because it's fairly recent, not that much has been written about it, and so it just started putting in the wrong names of people that got through to the final. People that were knocked out.
Was Elvis in there?
No, he wasn't. But and this is the thing, and this is what we're talking about. There were tennis players in there, and people, and you go, oh yeah, Andy Murray, and you think, oh yeah, he did play. Oh, he got knocked out in whatever round, and it's got him in the final. But then you go back another year and you ask it about the 2023, and obviously it's got a lot more data on that, and that's a lot more factual. And so this is that, like you're saying, it's really hard to know when you've got a bad answer. And
so back to the Google example, what we've all got used to doing is who played in the tennis and getting multiple responses.
Yeah.
And it's a bit of a ball ache because you have to sort of click through and read, and maybe you'll just take the number one answer, number one result as a definitive answer. And I think more often than not, given how the search engine algorithms work, it probably is correct. But you've also got other pages there that you can use to triage to double check that was the right answer. I mean, strictly speaking, in this particular example, the first result is probably going to be Wikipedia, right? And it's what's interesting about that example is we all know that Wikipedia is usually right, like by some very high percentage of the time. But we know that because that's created by humans and anyone can adjust the source of it, that still, if you really need to get that answer correct, that you need to triangulate that with something else. You need to cross-check it, right? By maybe going to the Lawn Tennis Association site or something that seems authoritative. So in that respect, you're doing research.
Yeah, exactly.
Whereas what the LLMs do is give you a single definitive answer. Yes, you can generate more answers, but ultimately most people will take the first thing that comes out, the same as taking the first Google result, and take that as gospel.
Yeah.
When the probability of it getting it wrong is considerably higher than, for example, with Wikipedia.
Yeah.
Okay. And so I think we're on the bad.
Yeah, and I'm going to do the ugly. which is numbers counting. You can give it tasks, give it a paragraph and tell it to count the number of the letter I's, and it struggles, and then if you start adding other rules, only capitalize, or there are some tongue twisters for humans with trying to spot F's and V's, because we say them the same, and so we kind of miss them, and they just don't count very well. And then when you start give it a list of numbers and get it to sum them up, I mean, it just I've seen examples where there's a fairly short list, 8 to 10 numbers in a column, and it says, oh yeah, and the sum of this is this, and it's just wrong.
But if I put 2 plus 2 in there, it's going to get it right.
Well, I think most of the time, yes. And this is where we're really going to get into this, is why does it get 2 and 2 right, and why does it get a list of 9 numbers of maybe thousands and tens of thousands, something which you'd manually do in a calculator or in a spreadsheet, do a sum. It's going to take you 3 seconds to type that in, and there you go, you've got the answer. You're not questioning that answer, and yet an LLM is again, you don't know whether it's right, and you do a sum, most of the time it's wrong.
And so let's unpack why that is.
Yeah.
Right. So it's probably worth a brief summary of how LLMs work.
Yeah.
They work by ingesting large amounts of text from across the internet on every subject, and they work, very simplistically speaking, by looking in the context of each word in each sentence, in each paragraph, in each page, or whatever, and using all the knowledge they derived from reading lots of stuff about the word cheese, and the fact that it sometimes appears in a recipe as an ingredient, but sometimes someone watched a movie and goes, that was pure cheese, and that it has a different context, right? And the reason that LLMs are good is because they read a lot of stuff and they encode that context within its internal state, so that it can hopefully recognize the difference between the two uses of the word cheese, and then it can build up sentences by just guessing the next word or the next character or whatever, by saying, based on the context of the thing that I was asked, this is probably about a recipe that includes cheese, and then can guess what other things need to come after that. So it's doing this to a degree, regurgitating what it's already seen on the internet, right, or out there in books or papers or web pages, and that's probabilistic. So it goes, in all probability, the next word after cheese is ham, right? Or the next word after cheese is bad, as in bad movie, right? And that means that it has to have experienced those words in that context, which is not hard to see in that particular example. But all it sees when it sees numbers is more characters, right? So do you want to just elaborate on why then that might go wrong?
When we think of numbers as humans, well, we learn maths, and so there are a bunch of rules for the maths, right, and logic, and we learn that as kids, and then generally it stays with us, and some of us are better than others, and and it can get quite complex. But we add numbers up via a bunch of rules, and and we follow those rules, and that's how we can always come to a consistent answer. Whereas, like you're saying, what's happening there with a large language model is it's not following a set of rules. It's trying to infer some rules, like you say, and those rules, inferring that by saying, well, most often I see the next word in this context is going to be something like this. So it's inferring a sort of probability. But if you put that to numbers, then you're saying, okay, well, when did I last see 156,222? followed by 327,000 and adding them together. Well, it's barely seen that. So now it's just kind of, well, kind of half guessing of how to put those together. It is not doing maths, and that's the difference. And this is the other ugly thing I think which comes out is that in the consuming of all the language, of all the mentions of cheese and how it's used in language, it's able to infer a structure to language. So even if it's kind of missing the next word, it knows it's an adjective, or or a noun that's coming. And so there are whole loads of semantic information and meta information around language, which is inferred because of the masses of language it's consumed. And so it does quite well at that structure. It infers that structure in terms of, like you say, predicting the next word. And as humans, we don't really have a description of what we call that, and we tend to say, "Oh, knowledge. Oh, well, it knows the structure, and therefore it comes up with the next word." And there's an argument to say, well, maybe we're doing exactly the same thing as humans, but the reality is it doesn't know. It's not looking inside of something, understanding it, and giving you the answer. And the other ugly thing where you see this is, going back to the code example, is when you write tests and you ask it to write tests for code. So it writes you some code, it runs, you go, this looks really good, now I need to write some tests to make sure that it works for all different scenarios. And you think, well, it's just written this code. And so as a human, you think, therefore it must understand it. It's written me a whole bunch of comments. It's explained the code to me. It appears to understand what's going wrong. So you say, okay, write me some inputs and outputs, and it can't do it. It'll write some inputs, and then it thinks, oh, and it tries to say, and the output of this input will be this, and it's wrong. And it's wrong most of the time. And the reason it's wrong is because it can't look inside that function, read the logic, and apply those rules. It's not what it's doing. But as humans, that's what we do. And this is where the disconnect comes. And it's the same with numbers. It's not doing the rules of logic and maths on numbers. It's doing something different. But we know numbers through logic and maths. And so we say, it must be doing that. And it's not.
When it sees a sequence of characters with no spaces, it sees it as a word, or it would often be called as a token. And the large language models, the middle M is important here, as you point out, because it relates to language. And although you could think of numbers as a language, and in a sense it is, it's nothing like the standard structures of any given human spoken language. And it doesn't have the same semantic rules, except in certain circumstances, like, A plus B plus C plus D. And that does have a certain semantics, like saying, cheese and ham and bread, right? And so that's how the LLM's going to see it. But instead of cheese, you've got 1947312. Instead of ham, you've got 2144321. Right? Has it seen those numbers before, and would they be in the same context as the previous set of numbers? And so almost certainly not, right? Because there's practically infinite combinations of numbers, especially once you really get deep into mathematical side of things. And so it has to look in memory and go, well, what have I got that's closest to whatever the first number I said was? And it's going to come up with something, and it's going to then try and guess the context of the next numeric type thing that comes out the other end. So it's probably looking for one 7-digit number plus another 7-digit number equals this, however many digits, going to be 8 digits or something, right? Like, so I should just give them an 8-digit number, right? It doesn't have any understanding of what happened in that operation. Now, I think it's slightly different with language, simply because the semantics that it's inferring, both in programming languages and natural languages, it's not got those rules wrong. It might have, the things that gets wrong are the facts, right? What it's good at is semantics, because that's really what it's encoded. it's encoded the knowledge of the structure of sentences in any given human language, and it does that ridiculously well, better than most humans. But it has to have understood any given word in any given context. So if you make up a brand new word like hobble snang flobblers, right? I don't think it's a word, but Google it, you might find it. It won't know what to do with that, right? So but it will be probabilistically, statistically close to another word in this case, the English language. So if you put that into a model, it's not going to freak out and go, sorry, can't do anything with this. It's going to find the next nearest thing, right?
Yeah.
The next nearest sort of phonologically or syntactically structured word that looks like that. And then it's going to see the context that lives in and start trying to give you a response based on that. And this behavior gets more or less worse depending on the temperature you've got set for your model. And a lot of people might not have been exposed to that, but you can increase or decrease the randomness of an LLM just by setting a particular value when you make a query to it. And if you turn the randomness right up, you get some seriously bizarre responses, because it's playing a lot more fast and loose with what it might guess for the next word.
Yeah.
So I think it's a fundamental disjunct between what LLMs are good at, which is anything semantically orientated. It's bad at facts, and it's ugly at maths, because at least the facts sit in with a semantic framework. And if it's got enough context and it's got enough information encoded in the model from when it was last rebuilt, so it does include the recent Euros rather than just the last Euros, right?
Yeah.
That it's going to be able to give you a good answer, probably because it's got the right facts encoded in the right semantic framework. But since numbers don't exist in that same semantic space, since calculations have their own language, it's never, ever going to be able to understand what to do with them unless it's seen every single calculation of any sort that could ever be made, which is not possible, ever. Right?
Yeah.
So, how does that bring us on to doing things like analysis? And in the case of what we're talking about here, we analyze business data, right?
Yeah.
So perhaps you've got your balance sheet or a spreadsheet that has the sales data for your business across the verticals for the past 5 years or something, and you just don't want to do the Excel stuff with it. But you want to roll that up and get some numbers from it, perhaps your average sales per month or something like that, right? And so you think, oh, I can't be bothered, right? I'm going to go and shove it into ChatGPT, and it's going to give me some numbers, right? And already we're into tricky territory here.
You can't just take a bunch of numbers which have been changed, summed up, the sum is wrong, and then you start taking that as gospel. I mean, if you had daily data and you wanted to look at it monthly, then all of that monthly data is a sum of every day, right? And if it can't add up, then you're straight away in big problems. I mean, I can't even go beyond that, because if you haven't got the right numbers, then anything else is just crazy.
So you can feed a table of data into ChatGPT.
Yeah.
In various forms, and you can do this, but you're not going to get good responses. But then I have seen it, right? I've seen it, and I think not directly into ChatGPT, but people have written business intelligence or analysis tools where you can use natural language that use ChatGPT to say, well, here's my spreadsheet, my data frame, whatever. Can you give me the sum of the sales data for the last quarter?
Yeah.
And they've got answers and graphs and all sorts out of it.
Yeah.
And all just using natural language, which is, a bit of a holy grail
Yeah.
in analysis terms.
Yeah.
But for business users. So if ChatGPT or any of the large language models can't handle numbers, how the hell is that happening?
Yeah, exactly. Yeah, I mean, and I think some of the main vendors, now, they're now saying this is, you get your analytics for your business just by asking questions, and have a chat, and it's going to give you all the graphs you need. Yeah, I mean, so these tools, and I use the word tools there because these tools are using these models, but there's definitely something more going on there, right?
Yeah, absolutely. And so to get round the fact that the LLMs can't do calculations, they lean on the fact that LLMs can write code, and say Python code, right? Although they can write pretty much any programming language, and that the fact that analytical operations in something like Python, from coding terms, are not very complicated. So the standard lingua franca for Python data analysis is a library called pandas that works in what are called data frames, which are equivalent to Excel spreadsheets with some extra stuff. And actually manipulations on data frames are quite easy, right, in terms of the amount of code that they take.
Yeah.
And if you want to write a full, from the ground up data analysis application, you're going to have millions of lines of code. LLM is not a lot of help there. But if all you want to do is take this data frame, roll up, get your partitions and your data, and then get some totals on those, a pivot, whatever you might do in Excel, these are all very standard, fairly lightweight application, lightweight operations from a coding perspective.
Yeah.
We're right in the LLM wheelhouse here.
Yeah.
So what's happening when you give it your data is that it says, right, well, what do I do with this data? I need to put that in a data frame. So start with Excel spreadsheet, let's put it in a data frame. Hey, ChatGPT, write me the code to put this Excel spreadsheet in a data frame. And then a second agent runs that code against a Python interpreter. ChatGPT does not do this, although some of the wrappers and the API wrappers around that will have interpreters bolted onto them. They can actually run the code, and some of the bigger innovations I think we're going to see is in terms of the LLMs themselves validating their own code and running their own code in situ, so that you can have these chained operations done by the model. But let's be clear about this: the model itself is not doing any calculations, it's writing the code to do the calculations. It then is not understanding the output, right?
Yeah.
So what happens then is that you say, right, okay, you've got it in a spreadsheet, it's got to a data frame. Hey, ChatGPT, can you give me the code to do a roll-up of this, of sales for the past quarter? That is, what, 50 characters of code or something?
Yeah, it's really, tight.
Run that. Hey, ChatGPT, give me the code to then translate that into a time series line chart with the x-axis rolled up to the nearest n million, and the main line being orange, right? It's gonna go off fairly involved bit of pandas and matplotlib code there, but not much. It's not hard. Any data scientist. GPT, easy peasy, run that. This agent is going to run it, that sits on top of GPT, and it's going to show you the graph back, right? Job done, right? So in that sense, the GPT has not handled those numbers. It's not even seen them.
No.
Right? It's not even seen the data, right? It's seen some entity called a spreadsheet and then some entity called a data frame.
And the key there is, like I say, it's the breaking out of the steps and then orchestrating those steps, some of which are going to the large language models. And then it's the orchestration of those steps, which generally get termed agents at the moment, that put those together. Now, as the end user, it's sort of interesting because you sort of don't care. It's just AI, right? It's just, you know, so you're telling me that on the one hand, there's this chat GPT or a model, and I can interact with that. And so you think you're having this long conversation with it, whereas actually you're not. But that's, you know, because what it's doing is it's every time it feeds the next round of chatting, it's adding on the previous rounds for you. So that whole idea that the model is remembering what you said is an illusion.
It feeds the whole stream in every single
time. So that's an illusion.
Interacting with it for the past 48 hours straight, generating hundreds of thousands of words. That's getting fed in every time, which is why if you're using the build version of ChatGPT, your billing will go through the roof quite quickly. If you're asking for long responses and then asking questions about those.
Long conversations. So under the covers, you know, things are now being broken out and orchestrated, and then you've got, you know, different technologies at different steps. But of course, as the end user, you don't really care. You're just saying, well, look, I mean, it seems the same sort of magic to me. I had some data in a spreadsheet, and I said, here's a spreadsheet, do some analysis for me, and it gave me some graphs, and potentially even taking the output of those graphs, and then again feeding that through a large language model to say, well, when you see a graph like this in the context of a business, what would you normally say about it? And then it's producing a sentence to say, oh, well, you know, your sales appear to have been going up over the last quarter, you know, because it can make those sort of inferences. And again, it seems like some intelligent analysis, which to an extent it is, but on the other hand, it doesn't really know that. It's just saying, well, you know, commonly when this has been seen in the big world, it means these things, and generally that's pretty good because, of course, if you're throwing these numbers in, this is what you're looking for, right? So when you go, oh, here's a table of data, and it comes back, gives you a graph, and says, oh, look, the line's going up, and that probably means this. Well, that's the question you're asking, right? So, you know, it feels again very magical.
Yeah, well, the thing is, it doesn't know that line's going up because it can't read charts.
No.
Right? And so what the agent has had to do in the background there is transform the data into a form that GPT can understand, and give it that information, and then have it regurgitate that into a decent sentence. What's interesting about this is that you know, you're throwing all this at GPT-4 or GPT-4o, and which knows everything about you know, Elvis Presley, and it knows everything about you know, diabetes medication, right? And you're asking it to pump out Python stroke pandas code, right? And that's entirely unnecessary. And so for it to know all that other stuff. And so there are versions of some of the more open models that have that are fine-tuned and tailored to handle Python or whatever your particular flavor of programming language is, and specialize in writing that type of code, and to create the right types of responses and to be able to handle that to and fro. And I think these models are still quite rudimentary, but are getting better and better and better, so that they will be able to handle more data, different types of data input, and perhaps they will be tailored to handle certain numerical types of input and be able to make some sense of them in situ rather than doing this code back and forth all the time. Things will definitely improve. But we get to this situation where using ChatGPT to do that type of operation is sledgehammer, crack a nut, right?
Yeah.
You've learned on all human knowledge to be able to do something that only relates to a very tiny corner of it. And if you're only ever using this through this particular channel as an analytical tool, you do not need Elvis's life history in there, because the GPT-4 is like a huge model, many terabytes of vector, you know, information that is just not necessary. And I think that's what we'll probably leave that to another conversation. But we can start to get into specialization of models
Yeah.
and how that works for things like business context and analytics. Businesses using their own LLM models.
Yeah. Yeah. So let's just round off then with, we've talked about what general models are good at, what they're not so good at, how they are now being manipulated to do specific tasks like analysis and coming out with some stuff. And then to round off there, it's like, okay, well, so how good is it, and should I be using it? And I think that's a really interesting question, because and there, lots of different ways here. But on the one hand, the fact that you might have some data, you can shove it in and get some fairly decent answers and some decent graphs, which are accurate because it's running code behind the scenes. It's not going into the large language model like that. And so now that trust is back up. So it is like having numbers from a spreadsheet just automatically graph themselves for you, without having to click anything, which is pretty good. But then you kind of get back to, okay, well, who's asking the question? And we've certainly come across people in many businesses, and usually there's one or two people who've really got quite a good handle on this stuff. It's not their job, they're not analysts, but they read numbers quite well. They understand what their business is doing. So a tool like this for them is going to be really helpful, because they're going to get some answers back. They're going to look at the graphs, going to be able to read them, and going to be able to understand them in the context of their business. And then go, okay, well, that's going to lead me to some more questions, or perhaps I can even take some conclusions at this point. But a lot of people don't. We've talked before about, okay, some of the numbers we'll use, median, mean, and then we'll see the skew of data, and they're sort of bread and butter starter points for us. But for a lot of people, I've just spoken some strange language, and what do you mean by that? And if you ask some analysis questions and it comes back, oh, well, you've got skewed data, you're going to go, okay, great. And you might be able to ask, what do I do now? And how good that answer is going to be, we're getting a little bit off piste here in terms of what the models are going to be good at doing. And so what I see across the board, what these models are very good at doing is getting you to a start for 5 or a start for 15 even. I don't know analysis that well. I can go and ask some questions and get some first level analysis. It's like learning a new task. When you don't know anything, you get some learning and you get a bit of practice and you go, great, but it doesn't make you an expert. And sometimes a little knowledge can be harmful. And then the question for us as sort of full on career analysts is, well, okay, well, what does that next step look like? And again, these models, we can have conversations with them, and they kind of can be useful for us. But the more in depth and the higher up these kind of knowledge and expertise that you get, the less at the moment, anyway, that these models are going to be useful for you.
Yeah, and so I think that this is all dependent on an agent being able to triage some potentially quite complicated questions and create a coherent stream of response that does the various analytical steps. Because just to get to that roll up of mean sales for a quarter, depending on the data for us, could be quite a few operations if the data is not in good shape, or it was used for a different form. We've got to cut it up and join it together and do all sorts of cleaning and restructuring on it, even to get something as simple as quarterly mean. And so I think still we're in the realm of something that an agent can orchestrate a model to do. But behind the scenes there's a lot going on, right? And therefore and there's a level to which there's a certain amount of abstractions that happen here that aren't particularly common, especially if the data is quite idiosyncratic, that models are just not going to be able to figure out a good way round, especially given I think a lot of these agents will rely on pre-canned scripts for certain types of data and certain types of operation to quickly get the answer that they need. This is a certain thing that happens all the time, right?
Yeah.
But I think that these more complicated operations, and when we get into much more complex questions that you can ask of the data, that might include things like, you know, clustering or forecasting or categorization on types of machine learning, that we're nowhere near a machine being able to take a simple question from a business user, that under the hood, if you pick apart that question, apply it to a perhaps quite a volatile data set, and realize that it's not a simple, you know, aggregation, that actually you need to do something quite exotic to get to that type of abstract thinking is going to be totally beyond these models as it stands at the moment, unless it just so happens that exotic operation happens to be very common. You're in a use case that's very common, and how often is that going to happen?
Yeah.
I mean, our experiences working with clients is that businesses, even if you take two businesses that on the outside look exactly equivalent, Sainsbury's and Tesco's, EY and PwC, right, under the hood, they are hugely idiosyncratic.
Yeah.
They've got hugely different approaches to data aggregation, blah, blah, blah. Yes, there's some crossover, but the idea that one, just because a thing worked here, that it's going to work there, is every person with any business who's worked in more than one business will know for a fact that isn't the case.
Yeah.
Right. And I think that's where things fall apart. If you assume that data is all homogeneous and therefore you can apply the same principles anywhere, you're going to come unstuck. There's probably more of these types of lift and shiftable use cases in scientific research, which is highly precise, relies on reproducibility and a very well tested set of methods and mathematical calculations. I think there's a high applicability of language models with analysis in the scientific space. I think that falls apart very quickly in the business space.
Yeah.
As anyone who's come from the science community into the business community will know, right? All bets are off. It does not work the same way.
Yeah. Yeah, and what we'll go into next time is, you know, the focus on building and honing individual models, and that applies here as well, because you've got answers to analytical questions about data. Your next obvious question is, oh yeah, and what about this? Oh, and what about this part of my business? And what about this part of the business? And the answer there is, well, have you got all that data? Is it accessible? And then you start getting into more of your data questions, which have been knocking around for the past 10 years, you know, like, well, should that be available to everybody? Is it available? How clean is your data? Have you got 17 sources of the same truth that are all slightly different?
I'm going to stop you there, because that's a rabbit hole.
Indeed.
Right. So a few subject areas there that we definitely need to cover off. One is models, localized models for individual businesses, how that works, why it's valuable, and how sort of industry is thinking about those things.
Yeah.
Another one is your data infrastructure doesn't disappear just because we have large language models.
Yeah.
So let's come back to those.
Yeah, definitely.
I think this has been very helpful.
Yeah.
Thank you. And we'll see everyone next time.
Yeah, excellent. See ya.